Okay, hi everybody. So what is a power series? So basically these are like infinite polynomials. Infinite polynomials. So here's something that's not a power series. Zeta of 2 is defined to be an infinite sum n equals 1 over n to the 2. Okay, so that's not a power series. Okay. What else is not a power series? 1 over x plus 2 plus 3x minus 5x squared plus 2x to the third plus dot 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 dot. Because of this is the power x to the minus 1. This is called a Laurent series, and we are scared of it. We don't learn those. So we only do power series. They cannot have negative exponents. They can only have things like this. This part is a power series. This makes it a Laurent series. Okay. What else is not a power series? A sum of a sub n e to the I n theta, where n is every integer, including negative. This is a Fourier series. It's not a power series. Okay. Great. Okay. So, what are we going to do? Oh, we have to say what is a power series. Okay, so never mind all these non-examples. Let's do the simplest kind of series, a power series. Any series, sum, infinity, n equals 0 can't be negative exponents, because we're going to do x minus c to the n, a sub n, where c in the complex numbers is fixed. This is called the center of the power series, and a sub n are all complex numbers, are the coefficients. Okay, so a power series looks like this. A simple version is when c is equal to 0, then we just get a n x to the n sum over n equals 0 to infinity. This is not a geometric series because these can be different each time. Okay. B. What is the radius of convergence? Okay, what's the radius of convergence? Every power series converges, not everywhere, but converges inside a disk of some radius called the radius of convergence, centered at C. In a picture, if here's the complex plane and maybe this is C, then there's some disk, and everywhere inside this disk, if we choose x there, or if we choose x here or here, anywhere inside the disk, then the series converges. Okay. That is the radius of convergence. It's totally not clear that it would be a circle. Why wouldn't it converge in some sort of a star shape? Why wouldn't it just converge inside of squares? Why wouldn't it just converge in sort of amoeba-like regions that depend on the a sub n's? Well, it converges inside of a disk that depends on the a sub n's. Why? Explain why this happens. Why circles? C. So, ratio test. Sequence of uncommon ratios, or not necessarily common ratios. What do we call it? A sub n. Now, here are the terms of our power series, so let's look at them. Take the absolute value of the nth term, divided by the absolute value of the n minus 1th term. Now, you see what's going to happen here is that we're going to get the absolute value of a sub n over the absolute value of a sub n minus 1. So the radius will depend on the coefficients, the a sub n's. And then there's n of these and n minus 1 of these, so we're going to be left with an x minus c to the first power. Nope, that's wrong. We need absolute value. Ah, I see. So this radius will be sort of the absolute value, the distance from C. The distance from C. Okay, now a circle is emerging. Now, why is this? So say that the limit of just the a sub n's, the uncommon ratios a sub n's, is some number L. Okay. Then the limit of the r sub n's, which is from the ratio test, is less than 1 exactly when x minus c is less than 1 over L. In other words, look right here. If this part goes to L, and we want the r sub n less than 1, well then just divide through by L, and we get the absolute value of x minus c is less than 1 over L. And so that radius is 1 over L, this radius right here. Okay, because it says that x it has to be close to c. It has to be within, x has to be within 1 over L of c. So that's when it converges by ratio test. Okay. This is one of those things where the notation, you might have to just do it yourself before you really understand it. Just because there's a lot of notation and you can get confused over my choice of notation, and you might like to do it yourself. Okay, that's all. Now, see if you can do this without looking. What's a power series? What's the radius of convergence? And why? Why does that happen? Why does it converge inside of a little circle? How big is the circle?